Okay, so now, if we have a chance to answer, we're just gonna go around. So Caleb, what does ENSO stand for?
El Nino Southern Oscillation.
Very
think.
good, okay, so that's this. He says El Nino. I should type this, I think. I'm going to, hold on. Wait a minute. Way too hard to write. Okay. So El Nino. Southern Oscillation.
Southern, that's the one I couldn't get.
So you have El Nino Southern Oscillation.
I got the same thing. I had to have El Nino blank.
What you should do is add Southern. El Nino Southern Oscillation. Okay, so that's what it means. Okay, so I know that you must have watched the video. Okay, what does the Southern you think, or what does oscillation mean? Anybody remember?
It's like the circulation of air, or just
So
the
this-
circulation in general.
So maybe the circulation in general, maybe.
South.
So Southern means in the south, where though? That's where does it start? Southern
Probably in the Pacific Ocean.
Pacific Ocean. It's really kind of towards the equator, right? But it's the South Pacific is where it occurs. Okay, but oscillation. You know, Matilda? Can you add something to oscillation?
Um,
No?
no.
Caleb? Oscillation, you know, what's that?
Isn't it like the cycle of how the water moves?
It's a cycle, so it changes, right? So one time it's doing this, another time it's doing this, so it changes. That's what it means. So it means there's a change, okay? And then the three parts. Do you know one of them, Hunter?
One of the 3 parts?
Yes.
Wait, you mean like,
Let me put this in first. I'll be
oh, yeah.
the Southern Pacific. Let me do that first, actually. Southern Pacific. Okay, 3 parts. There's 3 ways, 3 situations or 3 conditions for ENSO. One of them's in the name.
El Nino.
El Nino is one. Okay, don't say the other one. Let's try La Nina and Matilda. Think of it in your car. You're in park, you're in drive. What's between that? Begins with an N.
Nino.
No. Neutral. Neutral. Okay. So. Okay. And so yes. So it's El Nino, La Nina, and neutral.
So
2
it's
of-
not neutral phase though.
It is. It is. So there's a neutral phase, there's an El Nino phase, and there's a La Nina phase. And they're not like a set specific characteristics. Some are really strong, like it can be really strong La Nina, but there's not a set way that La Nina has to be. It can be very strong, very weak, but there's some certain things that happen in La Nina, certain things that happen in El Nino, and certain things that happen in neutral. Okay? And then maybe not that. Okay. So, and what does it have to do with? Like, what is occurring? Anybody remember from video?
It's the circulation of the ocean currents and the air.
Very good. So circulation of water and
And
air, right? Those kind of things. And then, okay. So very good. Any questions on that? So you guys are paying attention. I like that. Yeah, very good. Caleb, do you want to say anything?
Nope.
Oh, so in the ones that are similar are La Nina and neutral. I think I spelled neutral wrong. didn't I? No? Okay. All right. And what does El Nino mean? The boy. Why are they called the boy?
Because they're opposites.
They are. That's so the first one they named was the boy, and then La Nina means the girl, right? But the boy means something. It's referring to a specific person.
It's referring to Jesus.
It's referring to Christ because it was around Christmas time that this thing happens, this phenomenon. Okay. All right. So we'll talk about a little bit about that today. This a little further. Okay. So any questions on that? No? Okay. So then if you turn your paper over, we're going to look at this a little bit. So let me go to share screen. Continue. Where's my Miro now? Where is it? You know, I would think this would work. Pretty easy. Yes. Yes.
These are the same thing. This is this as the flash.
God bless you. Yes. Some of it. There's even more on the flashcards.
So I can cut these or print these out on flashcards.
You can. Let's see if I can get Miro to work here. I think this would be very easy, but it's not always working for me. Oh, I know why. I'm gonna stop sharing. You share screen. Let's see if it's on here yet. Come on, where are you? Try again. I don't know why I have to do this. There's probably a little trick to this. Does anybody use Zoom very often? Like it won't show me my screens. I want to share. What is it? There we go. I found it. Okay. So we're gonna look at these notes a little bit. I'm trying to find a way that I can like write on them on the screen. Everybody can see them. So Enzo, like I said, when we kind of reviewed, it means El Nino Southern Oscillation. And again, the oscillation means it changes. Sometimes it's El Nino, sometimes it's La Nina, and sometimes it's neutral. The normal thing is neutral. It doesn't do one or the other, it just does what it normally does. And then if something happens, it becomes El Nino. If the opposite happens, it becomes La Nina. Okay, and occurs in the Pacific Ocean, starts in the southern, just below the equator, near Chile, and works its way over to Australia. It's really a big thing in Australia. And it changes mainly water temperature. And it changes water temperature, which changes everything else. Okay. And then when it changes the water temperature, the weather patterns change, the ocean currents change, and it just changes a whole bunch at once. And it's connected to the jet stream movement. We'll look at that in a minute. Okay, how many people know what the jet stream is?
Fast moving currents of air
Yes. Why is it
that
there?
circulate the globe.
Why? Why is it there? Anyway,
Ocean currents,
why are there fast moving
streams.
streams of air in the atmosphere? Anybody? What's that called when air gets heated by the sun and it rises?
Yeah.
That's convection, right? So convection is where thing gets heated, it spreads out, it becomes lighter than the thing around it, and then it starts to go up, right? Because it's less dense, right? Like if you're in a fire, campfire, and you put something over, it'll push it up because it's forming a column of air. That's convection. The same thing happens on the earth. So that air rises up where it's heated in certain places, and it helps form these jet streams. Okay. And they're formed in certain places every 30 degrees about.
I
Yes.
made an airplane that hovered over a fireplace.
Did you? Yeah, it's pretty cool. It's
And
a,
then it came against the chimney and burned the motor into itself.
that's cool. Okay. So the three phases are neutral. And oh wait, before we do that, trade winds are the main thing that drives this. Okay, it's really like if we were going to draw a picture here, I'll be on the line number two. So I can go like this actually. So if we look at the earth, it has three wind belts. It's a very awful picture, but every 30 degrees, the winds change. So this is terrible. The trade winds are right here. 30 degrees either way, north and south. Trade winds are there. Okay. And they kind of go like this way. And they curve because of the Coriolis effect. And I don't talk about that too much. It's kind of complicated. It's kind of hard to understand. But just know that the winds like kind of bend because the earth is spinning and it's also round. It affects how the winds blow. Okay. And so trade winds push this along this process. And it really, they either die or they're normal, like there's normal trade winds. Does anybody know why they call them the trade winds?
Cause they trade directions.
That's a good guess, but that's not quite.
Have a hot dog.
Because that's what all the planes and stuff fly on.
Yeah.
Ships
Planes,
kind of
ships.
that are trading stuff.
Yeah, so if you think back in like Christopher Columbus and Balboa and all those people, did they have motors in their boats? What did they have?
Oh, that's fair.
Sails, right? So they had to find places that where there's a good wind, right? Well, they found these and called them trade winds because they were trading with other countries, and they would use those winds to carry them along to different places, right? Very good. Okay, so but something weird happens. They don't quite understand it, but the trade winds
Oh,
sometimes die. They just stop blowing. Yes.
so it's because the hot air over land heats up, it's convection, the hot air over land heats up. And it, in the daytime, it heats up and it rises and goes out over the ocean and then comes back,
Yes.
blowing in, and that's called an inland. This is kind of like it.
Kind of. Yeah.
And it blows inland and then it will switch overnight because the water holds more heat, but the land heats up quicker.
So we didn't even go over that actually. You're talking about a land breeze and a sea breeze, right? During the day, the ground gets heated up greater. So then hot air rises and it pulls wind in from the sea. But then at night, the ground cools off faster than the ocean. And then it goes the other way, so it blows out. So if you live next to the water, you'll notice that wind blows in during the day and out during the night. It's pretty constant. If anybody lived in a place where it was on the ocean?
But that was in our, Costa Rica.
Oh, yeah.
And then we had a tent thing set up on the beach and then
Yes.
slow. It like lift itself up one time a day and then almost fly off.
Oh, yeah.
And it, like push up against the ground.
Yeah, and that's like a land breeze and a sea breeze. Like if you live in a place on the ocean, you'll see those. Okay, but trade winds are just constant things winds that are occurring between 0 and 30 degrees. And if they're just normal trade winds, they take water and they push it from one side of the ocean, the eastern part of the Pacific, to the western part. And then and what that does is the water along in the tropics is really warm. So then it pushes warm water away. Let me draw a little picture here, actually. So if I can draw, this is Australia, pretend. It's not a very good picture, but and then here is, we'll say South America. I don't know, something like that. And then, so these winds are blowing, and then the warm water, we'll call it WW, it gets pushed this way. Because this is just right along the equator. So this is getting direct sunlight, and this warm water gets pushed over to Australia. But when the water gets pushed over, if we were like on the coast, look at this is, oh man, it's terrible. So if we were here, and this is the ocean, this is not the scale, right? So the wind comes along, these trade winds, and they push that water away. So then the water that's on the bottom then comes up. This is called upwelling. And then upwelling, what temperature of water do you think that is? Is it hot or cold? Compared to the top water. It's cold water, right? So, and because the water in the top's getting heated, but sunlight only goes so far into the water and they can't penetrate anymore. So just the top layer is heated, then underneath it, there's a colder layer. But it's colder and it's denser, so it just has to sit there until that other water gets pushed out of the way. And did you have a question?
Yeah, so what if does it go the opposite, doesn't it switch and go the opposite direction?
I'm gonna explain in a minute. So I just want to kind of show you this. So is cold water good or bad? Do you think?
Well,
For fish?
it's good.
It's good. It is good for fish. Why? Do you know why?
Well, not for fish that like.
Depends. So where to like if you're a small fish, what do you eat? Like probably really small like organisms. And if you're like little crabs or little zooplankton, right? And they kind of live in the deeper water sometimes, and they migrate. So during the day, they're dependent upon phytoplankton, which are like plants in the ocean, and the sun is shining. So then these zooplankton, small ones, they kind of hide out during the day because they don't want to get eaten, and they kind of feed at night. So then, but this cold water coming up, it pulls all this food with it, so it's good for fishing. So people noticed that certain times of the year, fishing was really good along that coast there, right? And then, but then some years they noticed there were no fish at all. And so they were kind of wondering what was going on. And that is, so this right here where the trade winds blow, that's a neutral phase. That's how it usually is, okay? El Nino is when there's no trade winds, they die off. So there's no wind blowing across, that water is not pushed, and then there's no upwelling. So the cold water does not come up from the bottom. The sea temperature is kind of much warmer overall because the water is not getting pushed. There's no cold water mixed in, and the fishing isn't as good. Like they can't catch as many fish because there's nothing for them to eat, so they're not in that area anymore. They're looking other places. Okay, so El Nino, the neutral is normal trade winds, warm water in the West Pacific. It gets pushed over Australia over here. It all ends up over here, and this is cold water, CW, along this coast here, this area. And all this warm water, and then warm water is really moisture, a lot of moist. So then that water gets over there and it raises up into the air and lots of storms. Okay? It's a normal process. El Nino, though, is the opposite. Weak trade winds. There's little water movement at all. So that water never gets pushed over there. And they have drought conditions. Does not rain as much. But also on the other side, they kind of get more rain in the South America and such. And the fishing isn't as good either, not as many fish. So that's El Nino. And the La Nina, maybe not, we'll be done here. Just don't want to beat this too much. Okay. So La Nina is really extra strong winds. So some years the trade winds are super strong. We're actually in one right now. It's dying off a little bit. And so super strong trade winds, more upwelling. So you get more cold water, the temperature of the ocean drops, and you get more severe conditions than you normally would. And then we'll watch this little video here in a minute. But this affects something called the jet stream as well. And I want to show you a real quick video on that. So, but that's kind of what these are. If you understand ENSO, it's just El Nino, La Nina, neutral. And it's either strong trade winds, pushing a whole bunch of water and causing a lot of rain in some places and drought in others. And then there's El Nino, weak trade winds, and then there's no water, and it's kind of drought, and it switches. So you have rain in the opposite end and drought in the other end. It's really dry. And then neutral is the way it usually is. Just, kind of like La Nina, but not as a great extreme. Okay, so that's kind of that. I want to show you this one video. Any questions, Caleb?
Nope.
Okay. So let me
No. Can you get
share
out?
something with you now. See if I can find this. Hope I can find this. So we go back to here. So what is the jet stream? Because it's usually a complicated thing. Because why would this change? So why would the temperature of the water have anything to do with our weather? Right? Why would that? But it does. It's going to kind of explain it here why it does. So I'm going to show you this. Can you see this video, Caleb?
What is the jet stream?
No, I cannot. I can hear it, but I cannot see it.
Yeah. Screen. Should be good now.
Okay, now I see it.
Jet streams are bands of strong wind that generally blow from west to east all across the globe. Jet streams form when warm air masses meet cold air masses in the atmosphere. Air masses have different temperatures because the sun doesn't heat the whole Earth evenly. Areas near the equator are hot, and areas near the poles are cold. The warmer air rises up in the atmosphere while cooler air sinks down to replace it. This movement causes an air current. These air currents are high in the atmosphere. On average, they travel about 110 miles per hour. In the winter, when the temperature differences between warm and cold air masses are more dramatic, jet streams can go much faster, 250 miles per hour or more. No matter the season, the primary jet streams only travel from west to east because of how Earth rotates on its axis. Jet streams are located in the middle and upper parts of a layer of the atmosphere called the troposphere. This is the height in the atmosphere where airplanes fly as well. That means airplanes can fly in the jet stream, especially when they're headed in the same direction the jet stream is blowing. This is why an airplane flying from west to east can make the trip faster than an airplane traveling the same route east to west. Jet streams can also affect our weather by impacting temperature and precipitation. Some weather systems ride the jet stream across the country, or if the weather system is far away from a jet stream, it might stay in one place, causing a heat wave or a flood. Monitoring jet streams can help meteorologists determine where weather systems will move next. This is important because the path of a jet stream can change quickly, taking storms in different directions. NOAA's GOES-R series satellites use infrared radiation to detect water vapor in the atmosphere. With this technology, meteorologists can monitor the location and activity of the jet streams. The GOES-R series satellites can give up-to-the-minute reports on where jet streams are in the atmosphere and where weather systems might be moving next. Find out more about Earth.
Okay, so I want to show you something. So this is just air, and they carry along like weather patterns, like highs and lows, and they cause them to form. Let me get this right.
Doesn't heat the whole Earth evenly. Areas near the equator are hot, and areas near the poles are cold. The warmer air rises up in the atmosphere.
Here is, yeah, that'll work. So here's the Pacific Ocean Sea, all red there, right? And there's usually a jet stream that kind of comes right by, Central America, kind of just carries storms this way. But when you have something like La Nina, the temperature of the water changes and it pushes the jet stream higher, right? So then the weather patterns change. Like the normal patterns that you might be used to in Alaska when it's neutral, it's really predictable. You can see how cold it's going to be and how much snow you're going to get. Like if you look at long-term climate, like how much snow we usually get. And if it's neutral, that's what it's going to be, right? But then if you have an El Nino or a La Nina, yes.
Is there any way to predict if there's going to be an El Nino?
Yes, absolutely. So they just measure the water temperature. They have satellites and little buoys out there, and they can kind of tell from over the years the temperature of the water, whether there's going to be a neutral, El Nino, and La Nina. So, and then based on the temperature, if it's super, super hot, then they know that it's a really strong El Nino, like just super weak, no winds at all. The water's just sitting there. If it's really, really cold, they know it's a La Nina, then somewhere in between it's going to be neutral, right? But as this water temperature changes, it can cause the jet stream to go way up and change the weather. That really affects Alaska when that happens. And I think that's usually on La Nina, like we have now. It's really changing our weather. It's a lot warmer and things like that. And when it's an El Nino, I think it kind of comes lower. But the weather patterns change for hurricanes and stuff like that. It really changes the weather overall drastically.
That's why there's like a tornado season in some places.
Yeah, that's,
They're
yes,
far
yes,
away.
yes, it is. Okay, so that's kind of that. Let me show you that. And then, so any questions on that? Okay, so that's kind of the jet stream. Some of these things are kind of complicated, and you don't need to know every single thing about it, right? So just to understand how they work, and then I want to show you. So here's a review. Which if you don't want, you might be busy. You can do it online as well.
Hey, it's like, how did you- what is that?
Kind of gives you the idea what I'm gonna ask them to test. If you can all depend on it. But you
That's
should
the
miss it,
reason
that
for this
video.
study.
I hope somebody do this for me. Yeah, this will help you study. So this tells you what's gonna be on the test. Whenever I give you a review, that's what I base the test on, okay? So let me go over a few questions here. I'm gonna share this with. What's going on here? Okay,
Is this a current
what's that?
weather report?
Yeah, it was pretty current, actually. I wanted to give you an Alaska one because a lot of times you don't, when they do weather units, they hardly ever share that. Okay. Okay, so you can see that review, right? Can you see that, Caleb? It's like it says you can, okay. So again, just to answer.
Yeah, I can.
So looking at these, are there any you think you might need help with? I can answer it for you today, if you want. Anybody looking at them real quick?
Not at the moment, but can we email you that? thing?
You can, yes. So please email if you have any questions. I'd say by the next class that I'd want you to finish this and take the quiz. So here, remember we did these? Okay, so you just have to tell me what they are, right? So what are the three, based on temperature, what are the air masses called? Anybody know? One of them? One's polar. What's the other ones? Arctic's another one. What's the last one? Right along the equator. It's tropical. And then they have them, whether they're formed over the ocean, what are those called? Maritime. And then if they're formed over land, they're called continental. And those two go together with the temperature. So it could be a continental polar, a continental Arctic, continental tropical. And little c for little c for continental maritime, capital A, P, T for the, and it goes MT and P and A. Okay, to do that. And let's see, types of fronts, make sure you know those. And then here's an isobar map. You have to answer questions on that. Okay, make sure you do your isobar lab right here. I'm kind of show this to you here. This is the lab. So,
I have that.
do you have it? And it looks. We're gonna move this. You have to turn this in. So it kind of looks like. I'm sure nothing else.
Is this also as an assignment?
It is, yes. This is an assignment, so make sure you're doing it. Okay, are you done? You good? So then Caleb, you know what I'm talking about here with this assignment? I can kind of show you here. Make sure you're doing these, it's really important.
Yeah, I think I might have actually finished it already.
Okay, so send it to me, take a picture and just send it to me. And I won't show you this.
Okay.
Miss this, but you have to draw something like that. Okay, I made a video that shows you how to do it. If you just go to the video, that's a isobar, which is equal pressures. You just connect them. And then you can tell. What's that?
Like connected up.
It is, just to connect the dots, same pressure, right? And then you know a high or low, does anybody remember what's the difference between a high and low?
High is a high pressure and low is a low pressure.
So how do I know it's a high?
Either, well, aside from the H.
What if it
because
wasn't there?
The H wasn't there, it's the distance between it's the
All
distance
those
between the
parts.
lines.
Now that has to do with wind, so the distance of the lines and they're apart, okay? If they're really close together, it's high wind, if they're far apart, it's a low wind. But how do I know, Caleb, do you know, how do I know if it's a high or a low? On my map,
You see how much the lines are stretched out?
not quite, that's wind. So the pressure has to do with, so if you go to the center and as you go out, If the pressure goes up, that means it's a low pressure. Okay, because wind always goes from high to low. That means if it's a low pressure, it's the lowest pressure in the middle and all the wind is going to the center. And then it goes up and forms storms and stuff like that. If it's a high pressure, it's highest in the center. So when you look at the inside, that'll be the highest pressure and all the pressures are low. So it's actually being pushed away from it. You really calm weather. And make sure you know that. Yes. Okay. So that's that. I wanted to show you that. And then there's the weather map. This is an Alaska one. So colors on the map, what are those probably for?
We kind of show like.
They show temperature, very good. And you can kind of see with the precipitation. What's that blue line?
That's cold front,
Cold front, very good. How do you know it's a cold front?
because it's blue, yeah. and
They're blue, very good. And what else?
It's the triangle.
The triangles, right? So triangle, blue and triangles means cold front. So if you couldn't even see the color, what if you're colorblind or something, right? Those triangles, what do the triangles tell you as well?
It's a good thing I'm not cold, right? It's going to be-
Which way it's going, right? So which way it's traveling. Yes.
That's the purple one. That's that.
Does anybody know?
Yeah, occluded for-
What?
It's the occluded.
Occluded, what's that mean?
It means like both.
It's both. It's kind of like, they're kind of, one is overtaken, like a cold front usually overtakes a warm front. So they're kind of mixed and can be unsettled weather. And then, so you know what the round ones are, right? Warm front, right? Okay, and then there's different conditions, so make sure you study that, understand if warm air is approaching cold air, what does it do? If cold air is approaching warm air, what does it do? They're two different things, so make sure you look back at the notes, okay? And in there. Okay, I just did the Enzo stuff, and then make sure you can know what spring, all the seasons, why do we have the seasons? Where's the tropics again? Exactly where are they? Yes, why are they 23.5 north and south? Remember? Because that's the tilt of something.
That's also there.
Tilt of the earth. So the earth is tilted 23.5. So as it goes around, the sun hits directly in that 23.5 north and south. Always good direct sunlight right there. That's why people go there, because the temperature is pretty much stable. There's always direct sunlight. Okay, and I think that's that. So make sure you fill all that in. And let me see what else I got here today. Go back. Go back. Yeah, oh wait, I have one more thing. Okay, so we're gonna do one more thing here. So we're gonna read this. So everybody's gonna take a minute to read this. The effects of the little girl, La Nina, on Alaska. Go ahead and read it. Make sure you put your name on it. Did you have this, Caleb? Put today's date and I'll be right back. Go ahead and read this and then we're gonna talk about it, okay? So do your best on it. I'll give you like 3 minutes. 4 minutes.
Oh, this is really.
Yeah, a couple more minutes. So when you're done, I want you to write a 2 or 3 sentence summary of that whole article. Give me a summary of it. Try to make it 3 sentences.
I just have one question.
Yes.
How often does the finding it? How often do they happen? Is that?
10-year thing, like an oscillation of 10 years. There's another one, the Pacific Dakota oscillation. The 10-year too. Really affects singing. I think it's connected to this.
This approach, I'm just gonna give you a fair warning. If I leave suddenly, it's because the phone died. It's like super close.
Have you had a chance to read this?
Yeah, I'm reading it right now.
I'll give you one more minute. Finish it as far as you can. 1 minute.
Wait, I'm supposed to write that?
Oh, you can actually, you don't have to actually write, but just think about you're gonna summarize it. We're gonna go to Matilda first. Matilda is first. Then we're just gonna go around, see what everybody thinks. You ready, Matilda? Give us a summary, Matilda. What is it?
Well, what is it?
What did you read there?
Well.
It's not too sciencey, I hope. It's not too science technical, was it? Or maybe sometimes I get immune to it. I was looking for something. So can you give us just a summary?
Well, in the story, it was like, Magneto was a terrible system. No, that.
Oh, okay.
And he
Okay.
got
We're in La Nina right now. I think this is an old article, actually, isn't it? Yeah, so this was 20 some years ago, right? So we're in what they're in right now. It's dying now, and it's changing. Okay, so Caleb, what do you got to summarize this? What would you say?
I don't know. That probably. Yeah, I don't know.
Gotta work on this. Okay, Hunter, what do you got?
So basically they're talking about how they just, it sounds like they just figured out how they could track it and stuff.
Yeah, this is
And then-
new. It's a new thing. It's not all that cool.
And then they were explaining that the last cold snap was a La Nina year.
Yes. Very good, okay. And Frankie, what do you think?
It was kind of like a statement of how they figured out, like you said, the connection between it and then like how drastically it was.
Yes. Okay, so- very good. So now what I want you to do is pick out the 3 sentences. You can only read share 3 sentences from this article. What would they be? I'll give you 2
Have a
minutes.
sentence.
3 sentences.
Okay,
They're the most important. You can circle them on the page. 3 sentences, Caleb. Sorry, Caleb. Can see the look on your face. 3 sentences. Make sure you second. We should come up with these.
can I choose part of sentences?
Yes, it's got to be 3. I'll give you another minute.
It's enough.
So you got 30 seconds.
The third one was like kind of like several times like that.
Oh, yeah. Okay, so now I want you to circle, if you can only have 4 words. 4 words to describe this.
We already know what we're
The
talking
4
about.
most important words. If somebody could only know the words.
Okay.
That describe this article. What was said in the article. So if someone can only know 4 words from this article, what should they do? Okay, got 2 minutes. Okay, Caleb? Are you there, Caleb? You might be gone. I see the D though.
Say that again.
Okay, so 4 words, Caleb. Pick the 4 most important words. Because we're gonna write a poem. Ready for this? We're gonna write a poem. Just wait.
Oh.
I hope it works. We'll see.
I've got 2 words. La Niña comes.
So to give you
La Niña comes.
3 words. 3 words. I said 4 though.
Yeah.
4 words. 4 words.
La Niña counts as like 2 words.
That's 1. La Nina is 1. What is this? Yeah. So now, what I want you to do though, before we start here, I want you to pick one of your sentences. If you can only have 1 sentence, what sentence would that be?
It
Choose,
would be,
start. Right?
I found it really, really long on that.
So usually when you do this, you have the students stand. They won't.
Yeah.
We're not,
Yeah.
doing that. We can't hold Caleb's in anyway.
Wait,
They would, it's, I know, it's, I don't go that deep. We're gonna try to write a poem about my name in Alaska. And so. Has everybody got their 1 sentence? You got yours, Caleb? Caleb? Caleb, are you there?
Yeah, I do.
Okay,
I have it.
do you have yours, Frankie?
Yes.
Do you have yours, Matilda? 1 sentence, 1, the best one,
Yeah.
most important. And you have yours, Hunter? Hunter, you have your 4 words.
Oh.
4.
I'm missing one.
Okay, so, and then number them, 1, 2, 3, 4.
Wait,
1's the most important,
1,
2 is the least, 4 is the least important. So put them in order. So your words, 1, 2, 3, 4. 1's the most important, 4 is the least important. Everybody got that yet? Gotta make decisions on this, I know. You got yours, Caleb? So we're gonna start with Caleb. Here's how it goes. Caleb says his sentence. Frankie says hers. Matilda says hers. Hunter says his sentence. Then Caleb does his number 4 word. We just go around. We just say it. He reads his sentence like that, and the next person goes. So it's gonna be Caleb. I hope this turns out. Frankie, Matilda, Hunter. So Caleb, you have to listen for Hunter. Because after Hunter, you go. Then we just do our 4 words.
So I do my least important. I do
word
my least important word then.
first, yes, and then 3, 2, 1. So is everybody ready? Any questions? This could be really amazing, or amazingly bad. Let's see which one it
Wait,
is.
we do our 4th one first.
You do your sentence first, 4th word, then 3rd word, 2nd, 1st. Okay, here we go. Let's see how this goes. Caleb.
For a sentence, I had La Nina affected Alaska by making by putting in a cold snap
Tim, Frankie.
for 19 days.
Enough cooling happens thousands of miles away. The interactions of ocean and atmosphere trade off. Onions effects that.
Very good. Matilda,
Wait,
your sentence now. It's not going as planned, but hey, it's good. Go ahead. I must not explain that well. Did you pick your sentence? Read one of your sentences.
I don't know.
Just choose one. Just pick one.
just pick one.
Okay.
Doesn't matter.
The winter of 1964, 1965 was a La Nina that used 38 days of total than believed for.
Okay, now we're gonna start again. Everybody knows what you're doing?
Yeah.
You got your sentence? So we're gonna start again to keep this a little more fluid. Yeah, okay, Caleb, you're up again. Go. The sentence.
So I have to say my sentence.
You do again. I know. Isn't this painful? Do you remember it?
La Nina created a 19-day cold snap of 40 below on Alaska due to give me a second. I had it.
I just
Give me a
just go
second.
Cold snap. Just go. So La Nina did what? What the cold snap?
It created a 19-day cold snap of 40 below.
Okay, even though
When it gets cold,
Okay, so
like
even,
really cold.
Frankie's going.
even though the cooling happens thousands of miles away, the interactions with ocean and atmosphere carry La Nina's effects at Alaska and all over the globe.
Matilda?
The winter of 1964 to 1965 was a long year that featured 38 days of temperatures colder than 40 below. La Nina should have, Whitman said that the 1998 through 1999 version of La Nina should have three noticeable effects in Alaska. It should be cooler than normal, more snow would fall, and Alaska thermometer should be below 0 more often than the non-La Nina.
Okay, then your number 4 word. Let's go. Caleb.
Cold snap.
La Nina.
For the goal?
Below.
Go ahead, Caleb. Again.
40 below.
Below.
Not simple. No.
Keep going, Caleb.
Give me a minute. I gotta find it. La Nina.
Drop.
Fall.
Cooler.
Last word. Most important. Caleb.
Give me a minute. I gotta find it. I had it on the paper. I had my finger on it, and then the paper moved.
Yeah, that's not, or not Mr. Mr. Bird. That's my,
We'll come back to Caleb. He'll be last. Frankie.
Effects.
I'll do that.
La Nina. I figured that one would be the most important.
Okay, very good. And then Caleb, you have yours?
Yeah, my was
You messed it up. Come on, Caleb. Come on. Not really, but you know.
I already said cold snap, didn't I?
it's,
I already said cold snap, didn't I? I did.
Most important word. We'll say it's cold snap. What's yours? Effects. Yoda.
Oh, well, you know,
La Nina.
La Nina.
Yeah. Okay, right. So that's kind of that. We can. It's hard to do, and not everybody's in the room. And it's kind of the first thing you do. It will do it again. It kind of tries to make it memorable, like we're thinking about important things. Okay, I just want to show you one more thing. I'm a little bit late, but I have to go to the ESP meeting as soon as I'm done here. But let me show you this. So one more thing. I'm going to show this on the camera. So hopefully, yeah, I think you'll be able to see this, Caleb. Then we'll be done. Okay, so I want to make sure everybody's doing this, right? Make sure that you get this done. Yeah, it's backwards. Come on now. Okay, everybody, I only have one person turn this in. Anybody else turn this in? I might have missed it. Anybody need
I'll
it?
see if I have it. I don't know.
Okay, so I'll give you one now. Does everybody know how to do this? Right?
Yeah, it's like.
So it's magnesium. Magnesium is a charge of +2, lithium is +1, zinc is +2, and potassium is +1. You combine them with each one of these polyatomic ions to form a compound. Yes. Okay, so do this, make sure you turn it in, and I think we're done for today. Thank you all for coming,
Okay.
and we'll see you soon.